So in 1996, a national vital statistics report indicated that about 4% of all births produced twins. Data from a large city hospital found only 14 sets of twins were born to 594 teenage girls. Is the rate of twin births the same among teenage mothers? State the null and alternative hypotheses. Choose the correct answer. The key is in the wording here. So, is the rate the same among teenage mothers? That does not really imply less than or greater than. I just asked if it's the same. It's either the same or it's not. So we're going to go with A, the not equals one. Okay. Find the p-values. Fill in the answer box to complete your choice. So for that, we're going to use StatCrunch. Going to use StatCrunch. So remember on StatCrunch, we go to stat, proportion stats, one sample with summary. Stat, proportion stats, one sample with summary. And we're going to put the data in. So let's take a look at here. So data from a large city hospital found only 14 sets of twins were born to 594 teenage girls. So 14 out of 594. Okay, and we're going to go to we're going to go to a hypothesis test. And then in the next box, we're going to look at the percentage. The percentage was 4%. So we're going to put the decimal form of that. We're going to change that to 0.04, not 0.01, 0.04. And then for this drop-down menu, we had already chosen the null and the alternative hypothesis to be equals and not equal to. So we're going to change. We don't need to change that because it already is not equal to. And we're going to go to compute. And it gives us our answer here. And you can see it gives our p-value of 0.041. So my p-value is 0.041. What is your conclusion? Choose the correct answer below. Let's go back to the PowerPoint, particularly down here. Okay, if our p-value is greater than or less than 5%. Now our p-value was 0.041, which is a little bit more than 4%. So that is obviously less than 5%. So our p-value here is less than 5%, which means our initial is false, and thus our alternative hypothesis is true. So our null or initial guess is false, and thus the alternative is true. So in this case, remember our null, okay, was that it was equal to 0.04. That is false, and therefore this is true, meaning that it is not equal to, it is not the same. So the proportion of twin births is not different. Okay. Well, not different means the same, so it would have to be B. The proportion of twin births for teenage mothers is different, therefore, because it is not equal to. So the answer for that one would be B. Okay. For next one, we're going to do the same thing. Okay, so we're going to go into StatCrunch. We're going to go into StatCrunch again. Okay, and once again, it's stat, proportion stats, one sample with summary. And let's look at the question here. A recent study examined 358 randomly selected children and found that 29 of them showed signs of an abnormality. So 29 out of 358. So 29 out of 358. Okay, what was our percentage on this one? It was generally believed that congenital abnormalities affected about 7% of large nations' children, so 0.07. Okay. Is this strong evidence that the risk has increased? So increased implies greater than. So when we do that, that means that is going to be our null and alternative hypothesis. That also means on StatCrunch on here, we're going to change this drop down to greater than when we go and calculate our p-value. So our p-value, okay, rounded to 3 decimal places, okay, our p-value is 0.207. Okay. And remember, let's go back to the PowerPoint. 0.207, that's more than 20%, which is obviously greater than 5%. So that means our initial guess is true, and thus our alternative is false. So in this problem, that means this is true and this is false, which means it is not increasing. Okay, so there is not sufficient evidence that the risk has increased. It's not increasing. Okay, and that is it for our sample Math Excel questions for Chapter 18.